Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. My name Ahmed Sabih Yusuf. Today I want to present my paper. Title is A New Approach to Solving a Transportation Problem Based on the Standard Deviation. First of all, this paper is present for the conference IEEE Symptoms on Computer Application and Industrial Electronics ISCAIE 2020. The paper ID is 16. So the outline is introduction, literature review, proposed method, conclusion, and the end is references. First of all, we define the title by this slide of introduction. Actually, all the slide is extracted from my original paper. So if you have any uh, misunderstanding, you can refer to my paper. Objective function is referring to the linear programming with optimization, maximization, or minimization to a function of variable. It is a subject to a combination of linear equation and or inequality and can be called a constraint. So the transportation problem is a special case of linear programming. Transportation problem is of MP complex issue in various cases as a small case transport problem. Graphic method or table dispatching method has the ability to work, but for the huge scale transport case problem, the result could be of graphic method or table dispatching method, and therefore it has been under the random and blind types. So we should obtain or propose a method that can be out of this method. The literature review, I want to talk about some previous work. So the day of transportation models, going back to 1941, when the F.L. Hitchcock and suggested a study entitled the distribution of a product from several sources to numerous localizations. The oral presentation is related to a first important novelty to a solution of transportation problem. In 1947, Combans proposed a letter called Optimum Utilization of the Transportation System. These two contributions show the development of transportation model, which included the number of shipping source and number of targets. So in this paper, we are going to propose a method. This method is summarized in the following steps. First step, determine the standard deviation for each row and column of the transportation model matrix. Second, select the row or column with a maximum standard deviation. Select the cell with minimum cost in row or column. Third step, assign as much as possible to a variable with least cost in selected row or column. Adjust the supply and demand and cross out the satisfy row or column. Fourth step is redo step 1, 2, and 3 until all demand are fulfilled. So you will see in my paper there is a flow chart of suggested method. You start the row and column and compute it to start the division for them. Take the maximum. If get the maximum, you go to column and row and then select the cell with minimum cost. After that, satisfy row or column to get the lower cost. If this path is not satisfied, you go from max rectangular box. You get, if you never get the max, you go to the compute standard deviation and repeat until get the max. So for the whole proposed method, the variable supply and demand always modify to meet the column and row results. So now we go to the result. You see the table comparison of virtual approximation method and suggested method. Actually, virtual approximation method is one of the methods that can consider as higher as much compared to the state of art, because it can obtain a minimum cost with optimally. So if you see the test problem, we take 10 test problem, we take dimension for every test problem. For example, for test problem 1, we get 3 by 2 matrix. So when we go through the proposed method, we see the x11, x12, x21 to x31, we gain 16. The minimization, we get 600. That equal to virtual method. That's mean we reached our destination, which we are targeting this paper. You see also the test problem 10, we use 3 by dimension of a problem, we use 3 by multiply by 4. We see the virtual approximation achieve, and x11, x21, x22, x31, x33, x34, 53, the value of z 53. As well, if we go to the suggested method with the same working cells, we get the 53. So that's mean that we can say that our proposed method can equality to, in term of performance, to the virtual method. So for conclusion, the new method for find the optimal solution for transportation model has been proposed. Various experiments via 10 problem compare and validated with the proposed method. The virtual approximation method obtained the best solution or near optimal as we compare through the literature from the table. True is this second method suggested that notice we also give more, that suggested method give more better solution for some problem. For instance, for problem 3 and 7, the proposed method achieves superior than the state of art for the optimal transportation problem application. That's mean we can say that our suggested method can be optimal or near optimal to the state of art, especially for the virtual approximation. The reference, we use for reference only Gupta 2008 and Roa 2009, Engineering Optimization Theory and Practice. So Taha Hussein, Operation Research and Introduction. This is one of the good research done in USA. Also Winston 1947, Operation 1994, sorry, Operation Research Application and Algorithm. Also is this done in USA research. Thank you so much. Hope to all to be fine and solve the coronavirus problem, inshallah. Salam alaikum.